So I'm Patricia Inácio, Bionews Service correspondent for Friedrich's Ataxia News. Dr. Zhen, thank you for being part of Friedrich's Ataxia News' official coverage of the International Ataxia Research Conference this year in Pisa, and to agreeing to being filmed and recorded for this interview. So our first question is, you showed in a mouse model of Friedrich's ataxia that long-term endurance exercise prevented the onset of disease symptoms and metabolic abnormalities. Which disease symptoms were analyzed?
Well, thank you for the invitation, giving me the opportunity to talk to you about our findings. And to answer your question, we have done the analysis for their exercise capacity, which is more analogous to for patient to a 6-minute walk, which is a standard test for a lot of researchers now. The other measurement we did was a cardiac function and a metabolic function called a glucose tolerance test, more like a test a doctor would prescribe for a diabetic patient.
So both normal and diseased mice voluntarily ran at the wheel. How often did they do this exercise in order for the effects to be noticeable, daily or 3 times a week? How long was each exercise session? And just a quick question, do you have any idea at this stage how this frequency and length might translate to an FA patient in order for that patient to benefit from regular long-term endurance exercise?
Mouse is a very, very special species, and they run at night. And in this case, they ran every night for about 10 miles every day. The duration is about 10 hours. They sometimes take a rest, and you don't have to be there to encourage them to do that. So that's the beauty of this system. To translate into humans, I don't think we know the precise answer yet. I would not be able to say how much exercise you have to do at this point without a very careful designed human study to give you that answer. But if you ask my gut feeling, I would say it's no different from any exercise training in humans. So I would predict that normal training for with a moderate intensity to a human to induce adaptation would be sufficient.
The Kiko mice eventually manifest disease symptoms, perhaps after stopping the regular exercise. How long were the mice followed beyond those 4 exercise months?
That's a great question, and we really hope to be able to answer that question, but due to the limitation of time and the funding, we have not done that experiment. So it will be very important to see whether lifelong exercise will completely prevent this onset of the disease.
So following, is the team planning to conduct further analysis into the molecular aspects and the mitochondrial related pathways that might be involved in the improvements seen with endurance exercise?
Absolutely, and we noticed the loss of mitochondrial function, but we have not found any particular regulation or regulators that will restore the function yet. So at this point, my lab has started to focus on ion metabolism. The regulators and the changes are the factors involved in ion metabolism, which is the primary defect of loss of frataxin. We believe that is a very promising direction.
And so what is the next step for this project? Are there plans to test this hypothesis in patients in the near future? And if so, which endurance exercise might be the best for Friedrich's ataxia patients to perform?
Yes, there are some discussions about human trials. The type of exercise we are talking about is endurance exercise, which is found by our voluntary wheel running model. But we also have received federal funding to do a comparison between resistant exercise and voluntary wheel running.
So mice have a shorter lifespan than humans. So what might be considered long-term beneficial endurance exercise for a patient? And any idea what 4 months to a mouse might equal for an adult? Also, the effects were seen in animals that began exercising at an early stage. If translated to humans, at what age do you envision a child needing to start exercising as a prevention approach?
Yes, we started at the age of 2 months to allow the mice to run. That's quite equivalent to like 7-year-old of age. The exercise lasted for 4 months, which is long. But we have noticed the adaptation even after 2 months of exercise and 4 months of exercise. Just because our duration was 6 months long or 4 months long with a 6 months of age, it didn't mean that the patient had to exercise that long. So, we live to about 80 years of age. Mice live 2 years, so there's a 40-fold difference. So 4 months is very, very long for mice. And so I would say, any type of exercise for a duration longer than days would be beneficial.
So is there anything else you would like to discuss or point you would like to further clarify?
Yeah, I want to emphasize that how important research is, and I also wanted to emphasize the implication of this study. This study implicates that if we can come up with a better and faster, more accurate diagnosis, and with a better understanding of the impact of exercise and the development of the disease, we may be able to find a way to have a huge impact on the people who bear the genetic defect.
Okay, thank you so much.
Thank you very much.